Oh, y'all, so like I said, this is 9.4, and it deals with logarithmic functions. And y'all, I'll tell you in the long run, logarithms, what they do is they find exponents. So first we'll look at a little bit of graph using the logs, and then we'll actually start finding logarithms. So for this one, we're going to graph y equals log base 3 of x. All right, so I'm gonna have to show y'all two ways depending on how old your calculator is. So let me go to my calculator and show you how I would graph this. All right, y'all, so I'm gonna go to y equals. Now, if you got a newer calculator, when you hit the, because we're doing a log base 3 of x, when you hit math, if you arrow down, newer calculators will have a log base right there. So you hit enter. And then mine had a base 3, so I would put a 3 where it's blinking and then arrow right and put my x. And then y'all, I would just hit my graph. So notice these graphs, it's making a horizontal asymptote on that y-axis because it cannot cross over it. And then notice it's only going to be on the positive side of the x's, and it sort of goes uphill left to right. So they want you to play up a few graphs doing that. Now, here's the thing. When y'all hit math on your calculator, are there any of y'all that do not have this log base on your calculator? Okay, so I am seeing one on there. So let me show you what you got to do in your case. So if you do not have the log base on there, you're going to have to do what we call change of base. So let me go to my paper real quick. All right, so remember, hit the math button, go down till you find log base. That's the newer calculators. If you do not have a newer calculator, when you graph this, you're going to have to do what we call a change of base. And the change of base is the log of the x divided by the log of the 3. So log of the x divided by log of the 3 will give me the same exact graph. So to put that in your calculator, you come up here, hit the log button, it's right beside the 7, hit that log, put in the x, then you're going to close parentheses, divided by the log of the 3. Now y'all watch when I hit graph, it's giving me the same exact graph. So it's a little bit more work if you got an older calculator, but that's what you're doing to do on that, okay? So now let me actually get into explaining what these logs are. So we got this property that says log base A of y equals x if and only if So this arrow means if and only if a to the x equals y. So here's the logarithmic expression on this side. This is exponential. So the little subscript a is the base. And remember, logarithms find exponents, which means that x is the exponent. And then y is the number or the result. So if you're given a log base a of y, it wants to know what exponent do you raise a to turn it into the y. And that's why when you punch that in, you get x, which is the exponent. Okay. Now, to check those, you could rewrite it as exponential. Take your base a, the exponent you get, and it's got to equal the number or that result. So I check them by writing them as exponential, okay? So y'all want to play with a few of these to get y'all good on them, okay? So let's find the logarithm. Or basically, let's find those exponents, okay? Whoops, forgot my M at the end. So these start at number 4, okay? So this one wants me to find the log base 5 of 25. So y'all let me write out what this is actually asking me. This wants to find the exponent that the base 5, so there's my base 5, it's the little subscript. So it wants me to find the exponent that the base 5 can be raised to equal 25. So y'all, what exponent would I raise that 5 to turn it into a 25? And there you go, that's going to equal 2. Now, watch this. Remember, we can do these on the calculator. So if you have a new calculator, so let me get off this screen. If you have a new calculator, you hit math, arrow down till you find log base, hit enter, put your 5 in, and then arrow over and put in my 25. So the newer calculators, you just punch that in, bam, it gives you the 2. Older calculators, remember, you use this log that's by the 7 up here. Remember, do the log of the result, which is 25, close parentheses, and then divide that by the log of the base, which was the 5. And then when you hit enter, you're still going to get 2 no matter which way you do that, okay? So remember, newer calculators do it the first way. Older TI-83s and some of the older TI-84s, you got to do it the way I did it that second time. All right, how about this? Log base 6 of 216. What exponent would I raise 6 to turn it into a 216? Now, older calculators, you can hit math and go down and get the log base. Newer ones, you would have to do the log of 216 divided by the log of 6. Oh, I already see an answer up there. Looks like it is definitely a 3. Now, if you want to check that, take your base 6, raise it to that 3rd power. Remember, 6 to the 3rd has to equal 216. All right, so 6 times 6 is 36. 36 times 6 is 216. So they will check them out if you rewrite them, okay? All right, log base 10 of 10. What exponent would I raise 10 to, which is my base down here, to turn it into a 10? And y'all, that is definitely A1. Good job. And y'all, actually, there's a rule that says log base A of A, don't care what these numbers are, if those match, that answer will be A1, okay? Log base 3 of 1 over 81. Now, I'll show you both ways on that. So the first way would be to hit math, go down and get your log base, hit enter. The base was a 3. The result was a 1 divided by 81. Now, anytime you have fractions like this, notice what these exponents are. They are negative. So fractions give me negative exponents. Now, the second way would have been to do the log of, what is that? 1 divided by 81 divided by the log of the base, which was a 3. And y'all doing it that way, you're still going to get a -4. So remember, if you got fractions, you're usually going to get a negative exponent, okay? So let me check that. So to check that, I would have 3 raised to the -4. So remember, you got an exponent rule that says when you got negative exponents, you put them under a 1 and make the exponent positive. So since it's negative exponent, I put all that under a 1. So the top is 1, and then 3 to the 4th is 3 times 3 times 3 times 3, which equals 81. So they will check out with these negative exponents, okay? All right, so before I do more, on the front of the calculator, you have a log button. That log button on the front of the calculator is really a log base 10. So if I do not write a base here, it is automatically understood to be a 10. And there's another button right under that one on the front of that calculator that is a LN. The LN is a special log, and it is a log that has a base of E. And this one's usually called the natural log. The first one, log base 10, is what we call the common log. These are the 2 buttons on the front of that calculator, okay? Any other base log, I got to use what we were using a while ago, the log base or that change of base I was showing you. All right, so continuing on with 8, they got a LN of 1. Well, also that one, you can use the LN on front of that calculator, so let's go do it. So let's go share our calculator here. So on the left side by the 4, that is a LN. That's not a capital I, that's a little L and an N. Okay, so hit that button, and then we put in a 1. So y'all, what exponent would you raise anything to turn it into a 1? What y'all think? Oh, I stumped y'all today. Well, watch this. When I hit enter, I'm definitely going to get them zeros. Good job. Remember, anything to the 0 power equals 1, okay? So you can do that with the log on here also. Put in a log. So hit your log button. Put in a 1. Guess what? It's still going to give you a 0. So if that result is a 1, the only exponent that'll make that happen is that 0, okay? Because remember, this is the e to the 0 equals 1 when you check it. How about this? Log of 1/10. So remember, this is a log of 1/10. This is really a log base 10. But that's the common log. That's on front of the calculator. So we can go to the front of our calculator. There's a log button. And then we'll put in 1/10. Close parentheses. So the log of 1/10 equals a -1. Remember, it's got to give you negative exponents if you're dealing with fractions. All right, y'all. Do this. Log base 3 of 3 to the 4th power. So what exponent would I raise 3 to get a result of 3 to the 4th? And y'all check this out. I can do that both ways on that calculator. Since it's a base 3, remember, I got to go in and use my log base. So I would hit math, go down to log base, hit enter. My base was a 3. My result was a 3 with an exponent of 4. Oh, I see answers already. And I'm seeing a 4 up there. So let's see, when we hit enter, we do get a 4. Okay, now the other way, you would have to do what? Log 3 to the 4th. Close those parentheses, divided by log of 3. Either way you go, you're getting a 4. Which means anytime you got a log base a of a to the b, the answer will always be the exponent b, okay? True every time these bases match those results. Oh, I had another tricky one. Log base 5 of the cube root of 5. So y'all, I'll tell you the truth. I usually rewrite these radicals as fractional exponents. So recall this. Anytime you got a radical, say an index of n, that's the same as this index of 3, we rewrite radicals as fractional exponents. It's always 1 over whatever that index is, okay? So if this was a square root, that would be x to the 1/2. A cube root would be x to the 1/3. So what I got here is my log base 5 of this 5 right here raised to an exponent for that cube root would be a 1/3. Now, let me show you this on the calculator. The calculator has a cube root on it. So to do that problem, let's see, I had what, log base 5. So I would hit math, go down and get my log base. Hit enter, put my 5 in, and then arrow over. It had a cube root of 5. To get a cube root on this calculator, you hit math, and option number 4 is a cube root. So you would hit enter and then put your 5. And y'all, that looks just like it. Log base 5 of the cube root of 5. Guess what? When we hit enter, I'm getting a decimal, but I'm going to turn that decimal into a fraction by hitting math and enter twice. So I get a 1/3. Okay. So it goes back to that property. When the base matches the result to an exponent, the answer will be that exponent. So remember, the 5 matches the 5, so that exponent becomes my answer. So you just got to practice rewriting those, okay? How about this? Log of 10 to the -4. So then we can do on the front of our calculator. But remember, there's not a number here shown. So since there's not a number here shown, it's like a 10. So guess what? This is a log base 10 of 10 to the -4. What's that going to give us? Oh, good job. That is definitely -4. So it's going back to that property there, okay? All righty, so watch this one. This one's going to have log base 8 of a 2. So y'all, anytime that result is smaller than the base you're starting with, you should get a fractional answer. So let's go punch that in. So I'm going to do that. Oh, someone's done got me beat. I got some 1/3s popping up. Good job. And I'm going to do that the change of base way. I'm going to take the log of my 2, divide by the log of my 8. And let's turn that decimal into a fraction. So y'all done beat me to it, and you get a 1/3. So anytime the result is smaller than the base, you're going to get fractional exponents, okay? All right, y'all, how about this? Log base 23 of 1. What exponent would I raise 23 to turn it into a 1? We are quick today, 0. Which means the log of any base with the result of 1 will equal 0 every time, okay? All right, playing with the LN. Now, y'all remember, when you do this in Math Lab, that's not a capital I, that is a LN for log natural. And then this one has e to the -5th. And y'all watch this. This one will be done right on the front of that calculator using that LN button a couple times. So notice on the left side is my LN. Now I got e to the -5. If you hit, good job, you're already there. So if you hit second LN, it brings up the e. Put in your -5. And let's see, you already got answers of -5. Good job. And that's sort of going back to that property, because remember, LN is really log base e. So log base e of e to the -5 just gives me back my -5. So this one I'll have to show you how to put in. This is a ln of the 5th root of an e. So what I do to this one, I would bring my ln over and then my e. I would write that 5th root as a exponent. So remember, it's going to be 1 over the index, which is a 5. All right, so ln of e to the 1/5. Now y'all watch this. If you don't want to convert that radical, so let me clear out. So I got my ln, I would hit my ln. To get that 5th root, when you want to do any root that's higher, you see down here, option number 5 has an x and then a radical. To use that option, when we do our ln, we got to hit the 5 first, since that's the 5th root. Hit the 5 and then go grab number 5 on the options, which is the x in front of the radical. Watch what happens when I hit enter. It puts that 5 up there like the index of my radical. And then all I got to do is hit second divide to get the e without the exponent. So if you want to exponent with e, you hit second ln. If you just want the e by itself, you hit second divide. But y'all watch this. When I hit enter, it gives me 0.2. So I'm going to hit math and enter twice. It gives me my 1/5. And see, that's why I rewrote it like this, because remember, ln is really log base e. So e, with a result of e to the 1/5 is always going to be that exponent of 1/5. All right, y'all. So let me just test y'all real quick. All right, this is for y'all. I'm going to do the log of 7 to the 1st. What exponent would you raise that 7 to get me a 1? Oh, good job. That would definitely be a 0. And that goes back to that property right there. All right, y'all. So see what this answer is. ln of e. Oh, I stumped y'all on that. Watch this. Remember, ln of e is really a log base e of e. All right, so now I see 1's coming in. Good job. Anytime that base matches that result, you're going to get a 1 out of that, okay? That'd be the same thing as doing a log of 10. Log of 10 would also give me a 1, because remember, there's no base. It's automatically a 10 on the common log. And since that base matches that result, it would also be a 1. So y'all, in the long run, just remember, all these logs are finding are those exponents, okay? So now we're going to convert from exponential to logarithmic. And y'all, I'm going to use my little property that says log base a of y equals x if and only if a to the x equals y. So notice the base of the log is the same as the base of the exponential. The exponent that the log finds is the same as the exponent on the exponential form. And then your result is the same as the result of the exponential. So you're just matching stuff up on these and putting them where they need to go. So starting at 17, they say, hey, convert to a logarithmic. Equation. So they're giving me 10 to the fourth equals 10,000. So they want us to write this using a log. So the first thing you got to figure out, what's the base of this log? Well, the base of this log is the same as the base of that exponential. So this would be a log base 10. So notice the log base became the base of the exponential. Now, the result here is the same as the result from the exponential, which would be the y. So y for me is 10,000. That's going to equal the exponent, which was a 4. Okay, so these have to be true. So when you punch in log of 10,000 on the calculator, it will give you a 4 to check that out. So y'all, this is what MATLAB wants on that answer. Oh, y'all, this one has 243 to the 1/3 equals, whoops, 243 to the 1/5, my bad, equals 3. So that's a 1/5 there, okay? So you're going to write it using logs. So remember, the base is the same as the base for the exponential. So your base is going to be the 243. The result is the 3. That's going to equal the exponent, which is a 1/5. So rewrite it and be done. All right, e to the 5th equals r. So bring down your log. The base of this logarithm is the same as the base, which is the e. The result is our r. That's going to equal our exponent of 5. So y'all, there's another way I can write log base e, remember. So since that's a log base e, I could use my ln of r equals 5. So y'all, anytime you get this log of e, you can change that to the ln notation of r equals 5, okay? So y'all, I'm gonna let y'all try this one. This is number 20. I got p to the k equals 81. So someone's asking me on this one, which one would MATLAB want? I think it would take either way on that one. It's quicker to do the ln, but you could, MATLAB will have that log feature on there. You'll punch it in, and then it'll it gets bold type if it's plugged in right. But you have to use a subscript on it this way. I think it'll take it either way though, for sure, okay? All right, so let's see if y'all got this. You got log base p, it looks like, of 81 equals k. Good job. They're trying to throw curveballs using letters like that, but still the same thing. Your base, your exponent, your result, okay? All right, y'all. So now they want to go the other way. They're going to want us to turn logarithmic into exponential. So these ones say convert to an exponential equation. So y'all, 21, they're giving us this. Log base 5 of 125 equals 3. So your base is the 5, which is the same thing as the base for your exponential. The exponent is 3, and 5 to the third has to equal that result of a 125. So same thing going the other way. Log of 0.1 equals -1. So let's see if y'all can get this. They don't have a base sitting down here. So since they don't have a base on this log, what base would y'all use? 10, good job. 10, perfect. So you're going to have a log, you're going to have a base of 10. Exponent would be that -1. And 10 to the -1 has to equal 0.1. So good job. You just got to watch out for the logs and the LNs on some of these. Oh, and here we go, LN. LN of 52 equals 3.9512. So y'all, how about this one? What would your base be for your exponential? So there you go. You got your E. All right, let's see. Our exponent is what? 3.9512. That's going to equal my result of a 52. So yeah, you just got to watch out for the logs that don't have the bases and for the LNs, okay? All right, so I'm going to let y'all do this one. 24 has the log base M of T equals -Y. Now, y'all remember also in Math Lab, if they give you capital letters, you better use capital letters. If they use small letters, you got to use small letters, okay? So what would y'all get on that? Oh, I think I see it. So I got M to the -Y. Good job. M to the -Y equals your T. Good job. There you go. Yeah, so the only thing you got to watch out for are those capital letters, okay? In Math Lab, make sure you use capitals if they do. All right, so then they come along and they say, hey, let's just play with the calculator and find common logs. And common logs are the logs that's on the front of the calculator, the LOG button. So let me play with some of those. So these examples want us to use a calculator, can find the common log. Now, round to 4 decimal places. There you also 25, I got log of 64. So I use curly parentheses, remember when we're estimating. Now think about this. There's not a base here, so it's a 10. So if you take a 10 to the first power, you get 10. So watch this. 10 to the first power is 10. 10 squared would be 100. 64 is in between 10 and 100. That means your exponent has to be in between a 1 and a 2 by process of elimination. So any numbers between 11 and 99, they're going to have an exponent of 1 point whatever. Any numbers that are less than 10 would have exponents that are less than 1. And then anything higher than 100 would have exponents greater than 2. So y'all hit the front of that calculator. You got a log button. So let me clear. So the front of this, I got the log button. And then I'm going to put in my 64. Now remember, we're rounding this to 4 decimal places. So the 1's in the 4th spot. So you got to look at the 7 behind it. Since the 7's 5 or greater, we would turn the 1 into a 2. So we would have a 1.8062. This is why they were having you round stuff with that E last week. So that you would remember the 4th spot depends on the 5th spot, okay? And then look, 1.8062 is in between 1 and 2, okay? All right, this one has a log of 2. Remember, that's the base 10 again. So I know 10 to the first is 10. 2 is less than 10, which means the exponent has to be less than a 1. So y'all punch me up a log of 2 and see what y'all get. Round me off to 4 decimal places. Woo, you're quick, girl. So I've got a 0.3010. Perfect. So did that come out perfect, or did you have to round that? And let's see. That was one, a log of 2. So good job. That 2 was lower than 5, so we kept that a 0. All righty. How about this? Log of a negative 36. So punch that one in to see what y'all get. Oh, look at that. So when I put in a negative number, non-real answers. So since there's not a real number answer for this, it's actually, instead of undefined, y'all, what Math Lab will use, Math Lab will say this does not exist. In the real world, it does not exist. So if you get that error message, there's a choice B on these, punch that and be done, okay? Because it does not exist in the real world. There's nothing I can do to a 10, no matter what exponent you give me. There's no way I can turn a 10 into a negative 36. That's not happening. I don't have the power to change signs using exponents. So we cannot do anything. So those will definitely be a do not exist. All right, same thing they wanted us to do with the LN. So how about an LN of 53? So round me off an LN of 53 to 4 decimal places, y'all. Oh, so I got two different answers up here. So let's see. So let's go to the calculator. So remember, LN button is right on the front by the 4. So hit LN. What we putting in? 53. And enter. So yeah, I'm gonna go with the 3.9703. I think you might have I bet you hit the log. Let's see, log of 53. Yeah, you accidentally hit the log. So remember on that one, use the LN on that. Okay, Kara? All right, y'all 29. I want y'all to do the LN of 143.4. So y'all push in the LN of 143.4, see what we get. All right, so let me see. 4.9656. Yeah, that's what I got. 4.9656. And that's a trick, just getting them rounded off to those 4 digits, okay? All right, y'all. LN of a negative 1.19. So last one, and then we'll change up. Oh, now I think this one was rounded on this 29. It wants you to round them to 4 decimal places. So that was what, an LN of 143. So LN 143.4. So let's see, the 4th decimal place would be the 6. And since it had a 3 after the 6 does not round. You're only going to round up if at the 5, 6, 7, 8, or 9 there, okay? All right, so what y'all get on this? LN of a negative 1.19. So definitely that does not exist. So basically, anytime that results are negative, you're going to get it does not exist because we don't have the power to turn these results into negative results, okay? All righty, so toward the end, it says find the logs using the change of base formula. Now, this only has to be people with the older calculators. So the log of A to the B, change of base is taking the log of the B, dividing by the log of the A. So it's what I was showing y'all earlier on for the people with the older calculators. It's always the log of the result over the log of the base, okay? Now, if you got math, if you can hit the math button and you got log base down there, I would just use that for these. So y'all round me out 4 decimal places for a log base 6 of 18. So if you're doing old school, you would do the log of 18, those parentheses, divided by the log of the 6. If you got the new calculator, you'll do this. So new calculators, you would hit math, arrow down till you found me the log base. Hit enter. That was a log base 6. Arrow over, put in your 18. So this is one method if you got a newer calculator. So that's going to give me what, a 1.6131. So Davis, I'm going to go with you because you're rounded off perfect. Now remember, the other way would be to do the log of 18, close parentheses, divided by the log of 6, close parentheses, and hit enter. Now y'all want to see something that's cool? Notice on both of those, I use logs. Watch this. ln, I can do the ln of 18, close parentheses, divided by the ln of 6, close parentheses. Once I hit enter, I get the same answer. So if you use change of base, it don't matter whether you use the logs or the ln's as long as you use the logs both times or the ln both times, okay? Either one of those will get you that answer. So what do we go? 1.6131, okay? All right, y'all. Log base 3 of 70. So either method y'all can do, punch that in and see what we get. Okay, you're quick. 3.8671, perfect. So old school would be log of 70 divided by log of 3. The other method, just go find that log base, put in 370 and be done. All right, y'all, log base 8 of 20. So what we got, a 1.4406. So I'm showing something different on that. So I'm gonna go hit that on the calculator real quick. So log base 8 of 20. Well, let me go punch that in real quick. So that was an 8, and then that was a 20. Oh, I must put that on wrong on my work. I'm getting that now. So 1.4406. So good job. All right, y'all. The last one on those is a log base 700 of 30. Punch that one in and see what y'all get on that one. On here, you was right the first time, 1.4406. Okay, so you was right that first one. So 0.5192, perfect. So now at the very last one, for 36, they just want us to graph both functions and pick a graph. So they're giving us f of x equals 2 to the x, f negative 1 of x. So we're using that f negative 1 of x because exponential graphs and logarithm graphs are inverses of each other. So remember that f negative 1 of x means it's the inverse function. So the inverse of an exponential would be a log base 2 of x. So this one's easy to put in. So I would put y1, I would put in my 2 to the x. Y2, if you got log base, you could put log base and put in 2 and an x. If you got the old calculator, so remember, this is the old calculator, you would do the log of x divided by the log of 2. So use change of base for older calculators. So let's go see what these two graphs do. I'm gonna go to y equals and clear that out. So y1, I'm gonna put into 2 exponent x. Then I'm gonna arrow down here to y2, and I'm gonna put in. Now remember, old new school, you could go down here, get that log base, okay? But I'm gonna do it without the log base. I'm gonna do it the old method. So the old method would be the log of x, close parentheses, divided by the log of 2, close parentheses. So y'all, they basically, I'm gonna have to go and turn off that shading, so I don't want this to shade. So let me hit enter. And go down here to the line and get that back on the regular line. Right there. So let me hit OK. All right, so I'm just going to graph this. So remember, the exponential left to right goes uphill. That's the blue line. They go uphill left to right. And they can't cross over the bottom of the x-axis. The red line is my logarithmic. They cannot have x values to the left of the y-axis because that was all those do not exist numbers. So your graph should look similar to that one when you graph this, okay? All right, y'all. So that's the gist of the day. They just want y'all to get used to learning what a logarithm is. And remember, in the long run, logarithms are exponents. Okay. So before I let y'all go, I'm going to give y'all a real quick review real quick over what we did today. So how about this? The log base 30 of a 1 equals. So what does log base 30 of 1 equal? So perfect, that is definitely going to be a 0. How about the log of 10? So that is definitely going to be a 1. How about the log base 5 of 1 over 25? So good job. That's definitely going to be a -2. Oh, let me see what I want here. How about the ln of e? So that's going to give me a 1. All right, y'all, my last one, log base 5 of a -125. So it does not exist. Good job. Y'all, so that's basically 9-4. So Wednesday, we'll come in and we'll start looking at properties of logarithms. So the properties is going to help us be able to start solving logarithmic equations in 9-6. So not real heavy this week. We'll do 9-4 today, 9-5 Wednesday. Next week, we got 9-6 and 9-7. That'll pretty much be the last material for test 4. The week after next week will be Thanksgiving break. That starts on like the 20th. So after Thanksgiving break, we come back. We got a week of class. And then that second week of coming back, we'll have class that Monday. But then finals will start Wednesday, the 11th, I think, of December. So not a lot of class left. So we're pretty much toward the end now. So for tonight, the main thing is knocking out y'all's 9.4. And y'all probably 80–90% of that can be done right on that calculator, okay? All right, so let me get my recording stopped, my share. So y'all, did y'all have questions? All right, let me see where my chat box goes. All righty, so I don't see no questions, so let me stop our recording.